In this video, we're going to calculate the double integral as an iterated integral. So, we're looking at the double integral over the rectangle 0, 1 cross 0, 1 of x over 1 plus xy dA. So, in this particular case, we could set this up with respect to x first and then y, or with respect to y first and then x. Well, notice that if we integrate this with respect to x first, I have an improper rational function as far as x is concerned, because I have a degree 1 polynomial in terms of x on top and a degree 1 polynomial, again in terms of x, on bottom. So I would have to do polynomial long division, or said another way, rewrite the integrand, which you can do. I just think it's a little easier to integrate with respect to y first and then x, because it's a simple u substitution if I integrate with respect to y first. So notice that if I let u equal the denominator, my du is exactly the numerator when I differentiate with respect to y. So an antiderivative for x over 1 plus xy is simply log of 1 plus xy. Evaluate that from 0 to 1. Notice that when you plug in 0 for y, you get natural log of 1, which is 0. So that term goes away. So the only thing we get is when we plug in 1 for y, which is natural log of 1 plus x. Now this one, if you want to do it by hand, you need to do an integration by parts, which is what I have listed over here. You could also look this up in a table of integrals. That would be fine as well. Here is my u, here's my du, here's my dv, here's my v. I don't have a lot to let u and dv be, and I don't know what the antiderivative is for natural log of 1 plus x to start with, so I'll let that u be my u. So notice again here when I do the antiderivative, when I apply the integration by parts formula, I take u times v, which is where this first piece is coming from, minus the integral of v du. I end up with another improper rational function. But notice that if I simply add and subtract 1 on top and then split it up, I can rewrite it pretty quickly. I could have done the same thing originally, but I just thought it was easier to integrate with respect to y first. In any event, again, if I take a minus 1 plus 1 on top and split it the plus sign in between the minus and the plus 1, I'll get this expression of my integrand, and here I can get this antiderivative pretty straightforwardly. And then again, plug on our endpoints and simplify, and we should get 2 natural log of 2 minus 1.